welcome to your learning, everyone. I am, of course, Mr. Jennings, and today what we're going to do is a quick lesson now, and I'll repeat this lesson in the chat because by request, that's what people are looking for. So there's going to be several times during this lesson where I'm going to ask you to pause me and then try and solve the questions, and then I'll show you how we would do it with our methods. So what I want you to take a look at are these series of numbers. I want you to see, can you tell me, first of all, what the rule is to create each one of these sequences? And then how you would go about finding the 10th term or the 100th term or the 1000th term. Okay, so go ahead and pause me, and then come back and we'll do this. Is this recording? It's recording. Okay, so for those of you who paused, thank you very much. And let's take a look at these things here. Clearly, this one is all the even numbers. So we can say this is all the even numbers, all right? And what we can do if we want to find the 10th term is we need to construct something that's going to look quite a lot like a function. You could do this, okay? You could, but you wouldn't want to, all right? You could say 2, 4, 6, 8, 10. Well, I'm just going to draw out a table, and I'm going to say, put all these things in the table, and I'm going to say this is the number of the terms. So this is like the first term, second term, third, fourth, and fifth. And I'm going to write those out 1, 2, 3, 4, 5. And then I'm going to put in what the term actually is. And I'm already using some of the language and nomenclature that we're going to be using. So the first term is 2, the second term is 4, the third term is 5, and 5 is 6, and the next one is 8, and then 10, and so on. But then you'd need to write this out all the way down to 10, and then you would find that that's 20, okay? I can already do that in my head. I don't need to write out the whole table for this one. You don't always have to write out the tables. So what can you do? Well, you can create a kind of formula that looks like this. You would say, well, the terms, the nth term of this series, an nth term, this is the first, second, third, fourth, fifth, the nth, okay, fifth, fourth, third, second, first, all right, and then the nth term means number n in this sequence is going to be given by a formula, and we can write this out here. You're going to take the first term, write it down, 2, and then you add something that's added repeatedly. We notice that we're just adding 2, adding 2, adding 2, here, adding 2. So I want to add 2 multiple times to find what the nth term is, and so I'm going to take it at 2 plus 2 multiplied by n minus 1. Why n minus 1? For the first term, I want to have 2 plus 0 2's. Okay, 2 plus 0 is 2. Okay, so 1 minus 1 is 0, so that will add 0 2's to this first term. If I want to check the second term, 2 minus 1 gives me 1. 1 times 2 gives me 2. 2 plus 2 is indeed 4. Okay, so this will predict all of the terms. So let's find the 10th one. T at 10 is going to be 2 plus 2 times 10 minus 1. This is equal to, we could have factored this too. 2 plus 10 minus 1. 10 minus 1 is 9. 2 times 9 is 18. 2 plus 18 is 20. Okay. And then t at 100, similarly, is going to be equal to 2 plus 2 times 100 minus 1. This is equal to 2 plus 2 times 99. And this is equal to, so 2 times 99 is 198. And 2 plus that is 200. Okay, and some of you are saying, why don't you just multiply n by 2? That's a very good question. Actually, we did. This is that. Okay, multiply this in. This is 2n minus 2 plus 2. So it's just 2n. Okay, this would simplify here to t to the n is equal to 2 plus 2n minus 2 when I expand this in, right? And the minus 2 and the plus 2 cancel, and it's just leaving you with 2n. So that would be fine also. Okay, let's now take a look at this one. So if you're looking at this one, maybe you noticed, oh, here we added 3. Okay, so let's number our terms first, second, third, fourth, fifth. We could write a table, but we're not going to. Okay, we added 3, but then we added 6, but then we added 12, but then we added 24. What's happening there? Well, multiplying is the simplest way to look at this. Okay, so here we multiply by 2, multiply by 2, multiply by 2, multiply by 2. Oh, we multiply by 2 multiple times. Oh, we've already seen stuff like this. Exponential functions. Okay, so geometric series look like exponential functions when you graph them. So we want to create another way of writing this down. Again, we're going to say that this is some sequence, and there's n terms in the sequence. So we want to find the nth term. This is the fifth term. This is the fourth term. Let's find the nth term. It's going to be equal to the first term, 3, multiplied by, here we call this the common ratio. Up here, these are common differences. If I subtract 2 from 4, I would get 2. So 2 is the difference between 4 and 2. But 2 is also the difference between 8 and 10, or any two numbers next to one another in this series. Here, they're not separated by a common difference because the difference is always changing, but the ratio is always the same. So ratio is about dividing. So if I divide 6 by 3, I get 2. If I divide 12 by 6, I get 2. If I divide 24 by 12, I get 2. It's always 2. Okay. So here, to find the next term in the series, I want to multiply by progressively more 2's. So I would have 2 there, raised to the power n minus 1. Okay. So for the first term, this would be 1 minus 1. That's 0. Anything raised to the power 0, here I'll write it out, x to the 0 equals 1. For all x, x is not equal to 0. Okay, so for any number that's not 0, when I raise that to the power 0, it gives me 1. 0, the only exception. Okay, so here, because 2 is not 0, 1 minus 1 is 0. So 2 to the 0 is 1, so this will give me 3 for the first term. And notice, as if I put in 2 there, 2 minus 1 is 1. 2 to the 1 is 2. 3 times 2 is 6. So this will predict all of these terms. So if I want to find t at 10, then that would be equal to 3 multiplied by 2 raised to the power 9. And t to the 100 would be equal to 3 times 2 to the power 99. Okay, so that's how you do those. Dun, 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 dun. Let's carry on. Arithmetic and geometric sequences. Okay, so this one is an arithmetic sequence. This one is a geometric sequence. And you're going to learn to recognize them and manipulate them today. So a sequence of numbers with a common difference that you get between consecutive terms. Consecutive, this word means in order. So 1, 2, 3, 4, 5 are the natural numbers in consecutive order. If I said 1, 5, 2, 3, 4, that's not consecutive because the number 5 was in the wrong place. Okay, so consecutive is important. And when you're organizing your series or your sequences, you want to make sure that they're consecutive. Okay, so we get these by adding or subtracting. Geometric sequences, they have a common ratio, and we get those by multiplying or dividing. So we have two flavors of the same concept. We have the sequences, they're the main concept, and then we have the flavors. There's arithmetic ones, there's geometric ones, and they do look quite different. Arithmetic ones, if we plot them on the graph, will make lines. Geometric sequences, when we plot them on the graph, will make exponential curves. However, these are not functions in the sense that they are continuous lines. They are more properly, if we look at them on a graph, a series of dots at regular intervals. Or with geometric sequences, they will be a series of dots at regular intervals. Okay, why is that? Because there's gaps. There's gaps in there, and there's gaps in there. We don't fill them in with the natural numbers. With the real numbers. We're using natural numbers. We're using numbers 1 and bigger to make that. So when we're creating an arithmetic sequence, we'll usually write them down in this way. So we have t of n. This is the term. Okay, the n is the number of in the series, in the sequence. So n gives you the number. So if I want to know what's the third term of the sequence, or what's the value of that term, then I would write down t of 3. Okay. And then the formula we use here, this is our first term. Okay. So whenever you're looking at an arithmetic sequence, you're going to look, what's that first term? We had one here, 2. So I just put that in there, 2. And then you need to find what's the difference between two terms, and you're going to put that in there. And you want to multiply the term number minus 1 by that difference to find any term in that sequence. These will create linear functions, as I mentioned. And you could create quadratic sequences and things. We're not doing that this year, but you can play with that if you like. And you can ask me questions like, Mr. Jennings, what's the rule for this sequence? And I will love to be challenged by your questions. So let's see. We want to solve for A and D. What are those letters again? This one is the first term. And this one is the common difference. So let's do that. The value of the first term, oh, there it is there. Very easy to solve, okay? And then the common difference, D, is I take two consecutive ones and I subtract them. And I want to make sure that I prove that to myself, that all of them follow that pattern. So I notice here that if I take a 0 and I subtract -4, just taking these two here and working on them, that gives me +4 because I'm subtracting a negative. Okay, if I take 4 and 8, I'm going to do that here. 8 subtract 4, that gives me also 4. So because that's constant, then it will be an arithmetic sequence. Okay, there's my D that I get by subtracting any two consecutive terms. So you always want to do, like, if I'm going to do, say, T2, I would subtract T1. Okay, here's T2. I'm going to subtract T1, the previous one. This is correct. If I did it this way, T1 subtract T2, that is incorrect. Don't do it that way. Do it this way. Take the later term and subtract the earlier term. Could also be T4 subtract T3. That's what I did here. T4 subtract T3. Okay, that will also give me D. This will give me D. This would give you -D. Don't use that. Okay, so that's how you find D. So now I want to write this as a series. So it's t to the n is equal to the first term, -4, multiplied by a plus n minus 1 multiplied by d, and d is 4. This here will generate the whole sequence. Okay, so now what if I want to find the 15th term or something? Well, I first need a general term. That's what this is called. This is a general term, and it's going to predict any one of the terms of the sequence. So let's take a look at this one. -13, -19, -25. And I notice, got smaller by 6. Got smaller by 6. That's the temperature outside right now, and I really don't want to go shovel snow. So here we are. I write this. I would do, say, T2 minus T1 equals -19 minus 13, okay, is equal to negative 19 plus 13 is equal to negative 6. Here is my difference. Okay, that's the d. So here's my general term. T to the n is equal to the first term. Oh, plus n minus 1 times negative 6. Okay, now you can do some algebra to that if you want and simplify it, especially if you're going to be solving for multiple terms, but I'm not going to, so I'm just going to work with this. So now if I want to know the 15th term, then that's equal to minus 13 plus 15 minus 1 times negative 6. Okay, 15 times minus 1 is 14. So negative 13 plus 14 times minus 6. Now do that. So 14 times minus 6 is negative 84. Yeah. So negative 13 minus 84. Well, that is simply minus 97. All right. So T15 is minus 97. There. T15 equals minus 97. Done. Final answer. That's how you work through these, everybody. So if we want to find the number of terms in the following sequence, so here, this one is a different question type. And we want to know, here is a sequence, and it's only this big. It doesn't extend out that way or extend out that way. So it's limited. We want to know, what number is that? What which t is that? So first, create your general term. So here, my t to the n would be equal to the first term plus n minus 1 multiplied by the common difference. This is growing by 3, so I'm not going to do the math. You can see that that's 3. Okay, and now I'm going to say, well, what is this? So then let's solve for n. 756 is equal to 3 plus n minus 1 times 3. Okay, and you'll see here that the algebra really clunks out really smoothly. 756 equals 3 plus 3n minus 3. Okay, 3 minus 3 is 0, so that's gone, that's gone. And so I just have that 756 is equal to 3n. So we're going to divide both sides by 3, and there's our answer, 756 divided by 3, which is, what is that? 600 would be 200, and then add 156 to that. 156 is certainly divisible by 3. 150 would be 5, so it's a 50, so it's a 52, so it's a 252. Okay, so therefore t, the 252nd term of this sequence is 752. Oh, 756, I'm sorry. 756, this one. So therefore, there are 252 terms in this sequence. Cool. Okay. Now, that's for arithmetic sequences. Now let's look at geometric sequences. So here, geometric sequences. We're going to have a general term here. So t to the n, this is the nth term. We read that as the nth term. So this is the value of term n, or the nth term, is equal to the first term, a, multiplied by the common ratio raised to the power n minus 1. I like to put brackets around that because otherwise I might think that this minus 1 is down here, and that would be a c, like a c transformation, just would lower the asymptote by 1. That's not what we've got here. Those are pretty hard to find. So let's use this. These create exponential functions, of course, as I already mentioned. Now, we want to solve for a and r, so let's do that here. 4, 12, 36. So a, this one. This is 4 is equal to a. Isn't that nice? It's very easy to solve for that, right? So when I'm creating my general term, the nth term, and then that's going to be equal to 4 multiplied by the ratio raised to n minus 1. Okay, so let's find the ratio here. And the way I do that is I divide two adjacent terms. So I'm going to take t2 and divide it by t1. That will give me the ratio. Okay, that will give me the common ratio. Or I could do t, and in fact I should do t3 divided by t2, and that should also give me the ratio. When these two things are the same, then I know I have a geometric sequence. This is how you recognize them. Okay, so 12 divided by 4, let's do that. 12 divided by 4 is equal to 3. Oh, but let's try this one. 36 divided by 12. Oh, look, it's also 3. Okay, because those are the same, then, yep, it's a geometric sequence. So I can put that in here, 3, and there. That is my common term. And now it says, then write the next 4 terms. Okay, so I would have, this is my first, second, third, fourth term. I want the fourth term. So to do that, what I'm going to do is here. And here I might create a table because I want to write out lots, or I just write it out. So here. If I want to do t fourth term, that's going to be equal to 4 multiplied by 3 raised to the power 4 minus 1. 4 minus 1 is 3, so this is 3 to the 3. 3 to the 3 is 27. 4 times 27, well, that's going to be equal to 108. Yeah, okay. And then, so I can write that in here, sure, 108, comma. The next one, well, it's just going to be 3 times bigger than that, right? You can also just multiply by 3 each time, but you can also use your this to calculate them. Sometimes working with this is easier, sometimes just multiplying by the ratio is easier. So here, the next one would be 324, and you'll notice that is 81 multiplied by 4. That's 3 to the 5 minus 1, 3 to the 4, it's 81. Okay, the next one would be multiply this by 3 again, so that would be 972. Okay, and then we were asked to find one more, so that would be a little less than 300. Sorry, 3,000. It's going to be, well, if I'm going to do that in my head, what I'm going to do is take 28, which is the difference between this and 1,000, multiply 28 by 3, and then subtract that from 3,000. And that's going to give me the next term. You can check my math and see if I'm right. So 28 times 3 gives me, oh geez, is that 84? Yeah, yes, it's 84. So 3,000 minus 84 gives me 2,916. So you check my work, see if that's 1, 2, 3, 4, 5, 6, t to the 6. The sixth term. See if that's the sixth term of this geometric sequence. Now, if I want to find here the 15th term, there, I'm going to need a calculator. 1, 2, 4, 8. Okay, these are the powers of 2. These are just the powers of 2, right? And if we look at it, we recognize it, and that's good. Shows that your mathematical ability is growing. But where this is 2 to the 0, we start at 2 to the 0, and then we go 2 to the 1, 2 to the 2, 2 to the 3. Okay, so the t to the 32nd term, well, I can have my a as 1. Okay, so a equals 1. My d, my common ratio is 2, and therefore I have the term, this is my general term. The nth term is 1 multiplied by 2 raised to the power n minus 1. Okay, so if I want to find the 15th term, it's just 2 to the 14. And I don't have my powers of 2 memorized that high because I'm not a computer programmer, but here we go. A 2 raised to the power, move my face, raised to the power 14 equals, there, that's the answer, 16,384. Okay. And then determine the number of terms in the following sequence. So now I want to know what term number is that. All right, first I need my general term. So this is 4, and then I multiply by 3. We've already looked at this one. So this is my general term, t to the n, is equal to 4 multiplied by 3 raised to the power n minus 1. How did I find 3? Well, I can take 12 and divide it by 4, or I can take 36 and divide it by 12, and that's all equal to 3. Okay, so there is my common ratio. So I put the ratio there, I put the first term there, and then I say, what number is that? Well, let's find out. 2916 equals 4 multiplied by 3 raised to the power n minus 1. Okay, and now let's divide both sides by 4. And we get 2916 divided by 4. 2916 divided by 4 gives us 729. Okay, 729 equals 3 to the n minus 1. So now we want to write these as powers with a common base. This is one way to solve this. And that way we can do this. So 729 is 3 to the 4 is 81. And so if I multiply 81 by 9, I get this. So that's 3 to the 6 is equal to 3 to the n minus 1. So 6 equals n minus 1. I'll just write that out. So now I can remove the bases, and I can just say 6 equals n minus 1. And then I add 1 to both sides. 7 equals n. Okay. Therefore, 2916 is equal to the 7th term. All right. So that's how you do it. So there you go. And I hope that gets you started. We're going to cover these lessons again in the chat in just a moment. Bye for now, everybody. Oh, and hit me up with your questions in the chat or by email.